Myself, Sunil Chintha, Assistant Professor in Mechanical Department, working in Marri Laxman Reddy Institute of Technology and Management College. Today, I'm going to explain automation in manufacturing subject. This is an elective subject which is having for fourth year students. Today, I'm going to explain what are the automation in manufacturing objectives, course objectives. Today, here we can see lower cost. First of all, in industries, lower cost, improves time market, automation, investments. These are the things which we are going to see in today's session. What is why we are including this automation in our industry? Why? Because see, let us see, to decrease the cost of the product, to improve the efficiency product life, we need to improve. Then afterwards, time to market automation. For example, if I go with this type of automation systems, we can improve the production rate in industries. Let us see in unit 1. Actually, what is there in unit 1 is numerical control systems, elements of NC systems, NC part programming, and methods of NC part programming, manual part programming, computer assisted part programming, computerized part programming, CNC, DNC, and adaptive control systems. These are the topics actually which is interrelated with automation in manufacturing. How interrelated? See, let us see. Here, just I'm going to show you some images. What are the images? For example, introduction to automation, how our NC, CNC, DNC is interconnected with this automation systems is here. Manufacturing of an bottle. Manufacturing of an bottle is one of the example in automation. If let us see, for example, if you take a bottle to manufacture a bottle, which is having very sensitive part. Why? Because which is a glass. It will break down whenever which falls from one place to other place. Such type of things we need to carry very sensitively. Because of that reason, we need to follow a conveyor belt system. A conveyor belt system. In that conveyor belt system, one by one, in a sequence of operations, how the bottle is going to be loaded, which has to be moved from one place to other place. Each and everything we need to know. Here, let us see, not only in bottle manufacturing system, in industries. For example, in an assembly line, if you go with an assembly line, if you are going to conclude with this type of assembly sections, where in if we take a car means in that car we are going to have different types of parts like a tires, engine, chassis, body frame, doors. Each and everything will be there. That will be if we are going to be included. If we are going to be included with a manpower, that is going to be very time taking process. Why? Because a human being who is going to be lifted the weight of that engine, that is not possible for an human. Because of that reasons, where we are going to use an robots, like robots in the sense where the chain cranes in industry, the large type of cranes will be utilized, where we are going to lift that vehicle from one place to other place. From one place to other place, we need to move from one station to other station. But in next station, we are going to have welding stations. In next stations, we are going to have assembly of with nut and bolt mechanisms like spanners, D-spanners, right, ring spanners, such type of things we are going to utilize. In the same manner, where in if we go with this robotic systems, where the welding station, here Here we are going to have different type of compression processes. Here, if we go with the next process, like a inline process where automation is going to be occurred, like an welding, then afterwards assembly, then afterwards movement of bottle from one place to other place, movement of object from one place to other place. That, like that, here we are going to see some more different types of automations, how in industry which is going to be utilized. Like an, first of all, if we go with this conveyor type of a belt where the robot systems are placed in a line. In the coming to the second one, in coming to the second slide, second diagram, here we can see where the cutting tools, screws, nuts, bolts, each and everything will be stored in an storage devices, where whenever we require, we will go directly to the storage system. There we can find what are the different types of bolts we are going to have, what are the different types of machines which we are going to have, what are the different types of assembly sections, what are the different types of components we are going to have. Each and everything we are going to see, we are going to find in a storage devices, where there the slot is going to be prepared. There the slot is going to be prepared in a sequence, in an order, where all the threading bolts are placed in one section, all the different types of spanners are in other section, nuts are going to be placed in other section, all the different parts are going to be sorted out with a part family, if we say, which is a part family. In a part family, for example, n number of threads for an n number of bolts. The according to the size we are going to sort out. That according to that one we are going to sort that different type of parts. Next one is coming to here, third slide. Third figure, where in a medicine devices, where the bottle cap, right, assembly of an bottle caps, right. Next, coming to next slide, we are going to have in an painting purpose, where the body frame of an vehicle, not only car, which is like a bike, lorries, trains, each and everything will be comes under this section only. Why? Because the painting process, this is a very, very, very dangerous situation. Why? Because if a human being is going to be under a painting process, if he breathe that painting into his body, automatically his lungs are going to be damaged. In order to overcome such type of a problem, we are placing the car bodies or train bodies or bike bodies, each and everything for painting purpose, we are placing on a conveyor belt. That conveyor belt which is going to be moved from one place to other place, from one place to other place, where there the chemical reactions will be there within that storage devices, where whenever the automation, whenever the process is going to be dipped in solution, there the painting is going to be painted to the vehicle structures. Likewise, we are going to utilize those type of components. Next, coming to CNCs. Why we are using these CNCs and NC machines, CNC milling, CNC lathes and milling machines. Why we are using this CNC lathes and CNC milling? In order to interconnect with this automation process. For example, if you take lathe machine, general lathe machine, if you take general milling machine, if you take a general type of a shaping, slotting, different type of machines we are going to have. But the thing is, here we are saying that CNC and DNC, where C stands for computer, N stands for numerical, control, C stands for control, computer numerical control systems, where we can reduce the time to do the production, to increase the production time, whereas in milling. But where in CNC lathe machines, and the difference between CNC lathe and milling, just now I will explain. In this type of systems, For example, numerical control system. What is numerical control system? First, before going to tell what is CNC and DNC, for these two interconnections, previously NC is there. NC in the sense numerical control systems. Whereas numerical control systems here, alphabetical letters and numerical numbers. By using these systems, we can run a machine. That is the main concept over here. Small definition is there here. Here, let us see. Numerical control is a method of controlling machines, machine tools using numerical data, numbers, letters, and symbols that are programmed in advance to perform machining operations automatically. For example, if you say, I want to do a machining process of a pen. For example, I want to do the production process for this pen. This is a cylindrical process, cylindrical object which is suitable only in lathe machines, not in milling machines. In a milling machine, we can utilize the flat plates. Flat plates, like for example, this is a flat plate where we can do the process where we can remove the material on the surface of this layer. Here, before going to do the performance, where depth of cut, feed, speed, that we are going to give in lathes. But whereas in CNC, we are going to write a program over here. Here, we are going to write a program over here. How we are going to write a program in the sense, here we are going to utilize alphabetics, numbers, numerical numbers 0 to 9, alphabetics A to Z. Elements of CNCs, first of all, we are going to how to write a program. See, let us see here elements of NC systems over here. Elements of NCs in this we are going to have different types of programs over here. For each and every letter, one operation is going to be connected. For example, if you see structure of NC part programming, how the program is structured in a sequence of operation. Here, let us see a part program consists of blocks and each block contains words, whereas N letter indicates sequence number. For example, if you take this is an object. I want to start from here. The machining process. Here, I'm going to read how a machine is going to be. Read this one. Why? Because in x-axis, x coordinate system, y-axis, y coordinate system, z-axis, z coordinate system. In 3 coordinate systems, we are going to give the information to a machine. The machine which has to function by utilizing these coordinate systems only. Let us see sequence number. Next one is G, stands for preparatory function, X, Y, and Z. Just now I said X direction, Y direction, Z direction. Why? Because, for example, if I take a cutting tool which has to move from top to bottom, left to right, right to left, or forward, backward. In a sequence, the cutting tool is which has to be moved. We are human beings. We know how to move and where to start, where to end. We know, but how could a machine knows which has to start from one point to other point, which has to start from here to there? How the machine is going to be known? What is the reason behind this one? The main reason is here we know very well regarding when the system is going to be operated. If we type a keyboard in a keyboard system, if we do letter N, which is going to be converted into binary systems. Binary to that system encoder will be there, that each and every information is going to be translated to the monitor. whenever in a computer system CPU, where central processing, in a central processing unit, that conversion is going to be occurred in the same manner. Let us see here, in a starting figure. In a starting figure we can find, in a starting figure we can find where how the program is going to be typed over here, in a X, in a Y, in a Z, the how much a speed of a spindle which has to be there, how much a speed of a cutting tool which has to be moved from in which direction, from X axis or Y axis, from where to start, from where to end. Each and everything we are going to write by using this MCU, Mission Control Unit, where this is a mission control unit. In this mission control unit, we are going to already in the keyboard is joined with a monitor. Here directly we can type a program over here. Here we can write what is, let us see here. I said N stands for sequence number, G stands for preparatory function, XYZ stands for axis movements, F stands for feed rate, S stands for spindle, T stands for tool number, M stands for miscellaneous functions. These are all different types of coding systems to understand a mission. We are going to write a program. For example, let us see by using two methods over here. One is the G codes, another one is the M codes. G codes is nothing but preparatory functions over here. Let us see preparatory functions. Z00 in the sense rapid positioning of a cutting tool. Cutting tool in the sense whenever I am going to give depth of cut to the workpiece, means we need to write a code over here Z00. Whereas in Z01, linear interpolation, Z02, circular interpolation in clockwise direction. Next, G03, circular interpolation in counterclockwise direction, whereas G90, absolute programming, G91, incremental program. Next, when coming to next slide, here M codes are there. Here M codes in the sense miscellaneous functions. Just now I said these are the G codes. Now we are going to deal with M codes. What is M codes? M stands for miscellaneous functions, where in this miscellaneous functions we are going to consider only few numbers from alphabetic numbers M01 to M09 up to M01 to M09. Within this limit, we are going to have different type of combinations over here. M03, for let us take M03. The machine will understand by giving this code, spindle should rotate, spindle should on, and which has to be rotated in clockwise direction, Next, M05, spindle stop. Whenever the spindle is rotating, in order to stop, we won't switch off the button, right? We won't turn off directly the machine. The main reason here, what we are saying to the machine is in a language where M05 in the sense spindle has to be stopped. The spindle has to be stopped. Next, M06. Here, M06 in the sense of tool change. This is the main concept over here. Tool change in the sense in the lathe machine we are going to have 4 different types of cutting tools at a time which may carry. But when coming to milling machine, here we are going to have a multi number of cutting tools over here. In a CNC lathe also we can utilize 4 plus 4, 8 cutting tools at a time. The machine which is going to be set, and the milling machine also same 8 plus 8 or 12 cutting tools at a time, which can pick up the cutting tool and which can operate and which can replace in a same position. ATC. We are going to say that ATC, automatic tool changer. Automatic tool changer in the sense we are writing a program over here. By utilizing this program, the machine which is going to be turned off or turned on whenever the process is finished. Automatically the cutting tool is going to be placed in that ATC and which picks T1, T2, T3, T4, T5, T6 up to T12, T8 cutting tools we can place on a disk, automatic tool changer disk. On the disk, we are going to have the different type of cutting tools over there. From where tool changer, we can change a cutting tool from there. Then afterwards, M08 coolant on. M08, this is the code where coolant is going to be switched on. Here, whenever the cutting machine is going to be come into picture, automatically when the cutting tool and the workpiece in contact with each other, automatically the friction generates, the heat generates. The chips are going to be very high temperatured one. In order to eliminate, in order to increase the surface finish, smoothness on the surface of the workpiece, that each and everything which is going to be controlled by supplying the coolant on, off. Whereas when coming to M08, this is coolant on. M09, this is coolant off. Whenever we are going to switch off, we need to utilize a code where M09. Whenever we want coolant, here M08 we need to require. Next, M30. M30 in the sense here, the program, the machine which has to understand. Where the spindle has to be stopped and the axis movement of a cutting tool which is to be stopped from one place to other place, that is going to be stopped in a little bit. That by utilizing M30, the program is going to be stopped. Types of programs here. Here we are going to have different types of programs over here. Whereas absolute program is there. Next one is incremental program is there. In coming to the fourth point, applications of NC machines. Main applications by utilizing this NCs and CNCs and DNCs. Why we are utilizing it in the sense to decrease the time being processed, to increase the quality of a product, to decrease the time, to increase the quality. We are utilizing this and cost also we are going to reduce. Obviously, by utilizing this NCC sophisticated one, by utilizing this thing, automatically the cost is going to gradually increase. Here, where applications of NC machines will be there in the sense is aerospace components is one. Next one, automotive parts, model and die making, precision making, medical devices. These are the different types of places where we are going to utilize this NC machines. Coming to next slide. What is a numerical control machines? Here, numerical control NC part programming defines the sequence of instructions for machining operations like tool movement, first one, cutting parameters, machine functions is one. Next one is programming accuracy, directly affects product quality and productivity. If we utilize manually, some part of time, a human is going to be stressed after doing 10 minutes to half an hour or 1 hour. I want to do this pen, for example, if I want to do the manufacturing process for this pen, I will do the taper turning process from here to here. Obviously, here, that why I am utilizing this, not a step turning process over here. Here I am utilizing a taper turning process over here. Why? Because here the diameter of this shaft is somewhat less. when compared to here. Here the diameter of this one is big when compared to here. Here, for example, if I consider this is an 100 mm, if I consider this is a 50 mm, obviously we are going to have taper sense over here. These information I have to give to the machine. That how I am giving in the sense by writing a program. For example, if I write a program n in the sense block number, I am giving a block number over here, right? Mission start, mission has to be started. But these things, sequence of operations, that if I write a program once, automatically which can develop around 1 lakh to 2 lakhs or 1 crore product also, that is suitable for each and every program. But in when compared with the NC missions, when compared to NC means in numerical control missions are going actually when the World War II started, at that time the machinery has to be supplied with a drastic fastnessly. Because of that reason, we need to supply to market. Because of that, for example, if I want to manufacture a car within a particular time, at that time what I require, in olden days, if I want to order a ambassador car, at that time, if I order on this date, next year this date, we have to go and we have to collect in the last in the years like 1947 at that time. Because in this, why they are doing means they don't have this NC, CNCs and DNCs at that time. Why? Manually they have to operate each and every operation by using a manual system only, not by utilizing these numerical controls, right? CNC, computer numerical controls, and DNC means direct numerical control systems are not there in olden days. Because of that reason, in olden days they don't have these systems. They use it in NC in the sense numerical control systems. In NC systems, we are going to have a punched tape reader, where like blind people, whenever they're going to read this lippy on a paper, how they are going to read this lippy on a paper, they're going to identify by using their fingers, and they can find whether which letter is there on the script. Punched tape reader. Likewise, in the same manner, punched tape readers in numerical control systems are prepared in the before when the World War II is going to be started. At that time, they prepared these NC machines in order to generate the machinery, in order to generate the guns or say, different types of components. At that time, they need to deliver the component very fast. They need to, in order to deliver the guns in a very fast manner. No need of taking 1 year of time to prepare a tanker, bomber, whereas in military army areas, they're utilizing such type of components. Within a less time, they're going to utilize. This is the main concept to develop these systems. So let us see here parts, classification of NC part programming methods. One is NC part programming methods are broadly classified into two things. One is manual part programming. Next one is computer assisted part programming. In a manual part programming, we are going to write by utilizing a manual skills over here. Whereas in a computer assisted part programming, CA, computer assisted part programming, means by utilizing a computer we can generate a program. Next, coming to next point, here manual part programming involves writing NC codes by hand. By writing NC codes by utilizing a hand, right? How we are going to utilize a program, how to calculate a program, calculator will be there, toolpaths will be there, coordinate systems will be there, cutting conditions will be there. Codes are prepared using G codes and M codes. G codes and M codes. Previously, I explained what is the G code and what is M code. What is the main function to run a mission? To run a mission, we are going to utilize only G codes. To run a mission has to understand the command. Whatever the command we are giving to the mission which has to understand, and accordingly the mission which has to be function. Next, coming to the what is a computer assisted part programming, CAPP. Here definition: computer assisted part programming is use of computer software to automatically generate CNC machine programs from CAD models. Here we are going to have a CAD models over here in the sense in a subject where CAD, CAD and CAM, CAD and CAM will be there. In a computer aided designing, CAD first session, computer aided manufacturing is the second session. Now we are discussing these CAM softwares only. Before that, whenever we want to connect, we want to run a machine, we need a program. We need a program. How a machine component should be designed. In that design, we are going to have different type. For example, if I want to design such type of a component like step turning. For example, this is a step turning process. Diameter of pi. Here, this is the 10. This is the 15. This diameter, step turning process. For example, if I take a step turning process over here, this is the pi 30. Pi indicates the diameter of a shaft. I want to write a program for this. The main thing is here, whenever the cutting tool which has to be in contact with the workpiece. This is a CNC lathe. In that CNC lathe, we automatically here he said that converts CAD design into CNC G and M codes by developing these systems. To develop such type of a drawing, I have drawn here a system for a stepped turning process. In this stepped turning process, 30 mm diameter, minor diameter is 10 mm. That is pi 10. This drawing I have to generate in by utilizing softwares like CAD, like CATIA. These are the softwares. A number of softwares we are going to have in for designing a component like a CAD, AutoCAD, like CATIA, ANSYS, ProE, Unigraphics, Hypermesh. These are the simulation softwares, at the same time designing softwares also. In this designing softwares, we are going to draw the figure in a particular dimension. For that particular dimension, just I am going to send to the machine shop, where there the program is going to be generated. Here CAD model is one, another one is CAM. Here in a designing process is one, another one is manufacturing process is one, where generates automatic toolpaths, reduces manual code errors, saves time and increase accuracies, allows mechanic simulation before production. The major advantages by utilizing this CAPP system is faster programming, high precision, improved productivity, easy design modification. The main applications by utilizing this CAPP system is automobile industries, aerospace industries, mold and die manufacturing systems. So these are all different types of a process where this CAM is going to be utilized. Next, coming to next slide. Here CNCs and DNC systems are there. In a DNC, I said previously, I have explained regarding CNC. What is a computer numerical control system? By utilizing G codes and M codes, we can write a program to the machine, right, where which has to be run automatically. That is a CNC systems. Whereas in DNC mission, in DNC missions are direct numerical control systems. Here, direct numerical control systems. In direct numerical control system, if I sit in a cabin, if I am going to generate a program, then I will ask a mission to run. Automatically 100 missions at a time, which is going to be run. That is direct numerical control. One mission, one person, 100 missions at a time, the functioning will be occurred. In the same manner, where mission tools in a scene, when coming to computer numerical controls, mission tool controlled by computer programs like uses of G codes and M code instructions, high accuracy and repeatability, suitable for small to medium batch productions. Each machine has its own control. Coming to DNCs. DNC systems, central computer controls multiple CNC machines. This is the first point here. Coming to next one, programs are stored and distributed from main server, reduces memory limitation of individual missions, suitable for large scale production systems. These are all different types, difference between different types of compared to CNC to the NC. Key differences, main key differences are, in a CNC mission, one controller. Coming to DNC, one central computer, multiple machines can be operated. I am a single person, I can operate 100 machines at a time by writing a program. That is nothing but a direct numerical control systems. Coming to adaptive systems. Coming to adaptive control systems. In adaptive control systems definition, adaptive control system is an advanced control system that automatically adjusts machining parameters like speed, feed, depth of cut in real time to optimize performance. Main purpose is maintain optimum cutting conditions, improve productivity and tool life, reduce machining errors. Types of adaptive control systems are, here we can see, in a preventive overload, tool breakage and excessive force. Next one is ACO, adaptive control optimization, maximum production rate under safe limits. Advantages: high efficiency, better surface finish, reduced tool wear, increased machine utilization. The main applications are here is used in CNC milling, turning, drilling and automated manufacturing systems. These are all the different types of systems that we can utilize in adaptive control systems. Thank you. Thank you very much.